जाएगा ना।
मार्क्स एक सेपरेट शीट जो एक्सेल शीट में बनेगा वो हम तुमको प्रोवाइड कर देंगे पूरा एमसीक्यू होने के बाद।
ठीक है सर।
Continuity of a function of two variable. A function fxy, a function of two variable fxy is said to be continuous at a point AB if the limit xy tends to AB fxy is equal to f of AB. So limit xy tends to AB fxy if equal to f of AB, then the function will be continuous at the point AB. Now, a function is said to be continuous in a domain R. A function is said to be continuous in a domain R in a region R if it is continuous at every point. If it is continuous at every point of the domain R. What is the working rule? Working rule. Step 1. First, f of AB should be defined. Step 1. F at the point AB should be well defined. Step 2. The limit xy tends to AB, f of xy should exist. And third is the limit will be equal to f of AB. This is the 3 rules for working to find the limit of a function at the point AB. This is the function fxy. The function fxy is given as x cube minus y cube by x square plus y square when x and y both not equal to 0 and equal to 0 when x and y both are equal to 0. So step 1 is the function fxy at the point 0, 0 should be defined. That at the point x equal to 0, 0 function is equal to 0. So the function is well defined at 0, 0. And step 2 to find the limit xy x tends to 0 and y tends to 0 fxy will be equal to put y equal to mx. Then this will be x tends to 0, y tends to 0, and y equal to mx. So this will be x cube minus m cube x cube by x square plus m square x square. This will be limit x tends to 0, x cube 1 minus m cube x square 1 plus m square x square. So this is limit x tends to 0, x into 1 minus m cube plus by 1 plus m square. Now since x tends to 0, so the limit will be equal to 0. So limit exists at the point 0, 0, and the value of the limit is what? Will be equal to 0. And step 3, the limit value x tends to 0, y tends to 0, fxy is equal to the functional value at 0, 0, because both are equal to 0. So the function is continuous at the origin. So the function is continuous at the origin 0, 0. Example 2. Discuss the continuity of the function fxy. Fxy is defined as x by x square plus y square when x and y both are not equal to 0 and equal to 2. Equal to 2 when x and y equal to 0. Step 1 function is well defined at the point 0, 0. So we have to check the continuity at the point 0, 0. So step 1 is function is well defined. The function at 0, 0. Step 2, find the limit. So limit xy tends to 0, 0 fxy. Limit xy tends to 0, 0 and put y equal to mx. And this will be x by root over x square plus m square x square. So this will be equal to limit x tends to 0, x by x. So this is root over 1 plus m square. That means the limit value depends on m. So we can say that the limit does not exist. So we can say that limit xy tends to 0, 0 of the function fxy does not exist at 0, 0. So fxy is not continuous at origin. So f of xy is not continuous at 0, 0. Now example 3. Example 3. fxy equal to x square y by this, and if xy not equal to 0, 0.
So,
Bolo.
so when we were proving the limit exists, sir, proving that the limit exists is a concept that cannot be done in 1 to 2 steps, because you were telling us about the paths. So path can come from anywhere. Any equation can be used.
Any equation can be used for this case. For the second example, for not for
Sir, for not proving limit exists only if, sir, it's like, for example, I say this sentence is correct, and you have infinite examples to check in that sentence. But if you are able to prove only one sentence that related to that, then that becomes false. So over here, if only one equation that y equals to mx is false, then that is understandable that the limit does not exist.
right.
But sir, in example one, if
Example
we
one,
take y
right.
equals to mx, we get 0 at y equals to mx, but we might not get 0 at y equals to mx square or some other equation.
Yes.
So,
But
sir, how are we saying only by y equals to mx that the limit exists?
actually, working rule, already said that working rule, you have to check actually when x square equal to y square. That is the working rule. When x square equal to y square, that means x equal to y. If x, for the case of x equal to y, the limit exists. That means the limit exists. If you put you can put y equal to mx square, mx cube. In all cases, the limit exists. You can check.
So, to shorten our cases, we can simply place the denominator equal to 0, and then we can solve for cases for x or
No,
y.
denominator equal to 0. No, denominator equal to not 0.
Okay.
Just put x square equal to y square. That means if there x square equal to x square plus y to the power 6 equal to 0 in denominator, then you have to write x square equal to y6. That means x equal to y cube.
Okay, sir. So that is possible. Sir, for example, again, that thing is possible for this example. For
Yes.
what if there is some equation? For example, there is an equation. For example, the denominator is x square y. Then what we'll do?
X square y. We're coming all the cases. All the cases. Actually, you will have a idea for which function is continuous, which function has limit or not. You already have an idea.
Sir,
So,
proving that the limit does not exist, we know the
uh,
idea that we'll take some equation by which all our x's and y cancel out. So that means if our equation depends on m, then we can say limit does not exist. But having an idea for the limit exists from all the paths possible, how is that coming into picture?
so you can check here for the example one, the limit f1, f1,
Yes, sir.
f2, f3, and f4. All the cases. If all the limits are equal to are same, then we can say the limit exists.
Sir, then my question was same only. Why are we going only up till f4? Are the paths not more than that? We have multiple equations that will be formed besides y equals to mx and y equals to mx square.
You
So
can check uh,
is it
f5
like
also,
a
but
written rule or something, or taken into multiple cases that if we prove for f1, f2, f3, f4 equality, then that means it is a limit will exist for all other paths also? Is it something like this?
no, actually, corresponding to the function, you have to check the limit corresponding to the function.